Hi, my name is Kate Chapman, and this is my presentation for Lab 3. So, just to start off, the goal of this experiment was to determine the distance dependence of a small bar magnet's magnetic field both on and off axis. To do this, we needed to use the Biot-Savart law and the distance dependence of a bar magnet. By manipulating those two equations and solving for different variables, you're able to find what mu is. The assumptions that we had to make was the magnetic true north, and that if we aligned ourselves properly with it, it would have a negligible impact on our magnetic field in the x direction. The results I got was a distance dependent of negative 1.34 and a mu of 2.8. So this is all of my data. If you want to look through it, it's fairly consistent, so that's good. And we got a distance dependent of negative 3.14 from my y equation, which is reasonably accurate, as my TA said that we should be looking for a value of roughly 3, so that's pretty close. From there, we can do our calculations. So on the left, we have our known values. So we started off with my y equation, which gives us a distance dependence of roughly 3.14. We know from this equation, that the ln of my field, my B total, is negative 14.55. We know that R is 1. And then the value of mu naught over 4 pi is a constant that we know to be 1 times 10 to the negative 7th. We can take this equation where B total equals KRN. We can take the ln of the entire equation and then solve for K to get K equals 4.8 times 10 to the negative 7th. From there, we know the equation for distance dependence of a bar magnet is K equals mu naught over 4 pi times 2 mu. We can then manipulate the equation to find mu, which ends up being 2.8. So here's my code. We just start by making the magnet and then the dipole, and just assigning it to different axes. And then we go down further, and we do more axes, and then we get our result by doing B of the 45 degrees. Which then gives us this model, which is fairly accurate. And so then the questions: if you hadn't oriented your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field, how would your results have changed? Well, in that case, we wouldn't have been able to find the x component of the magnetic field of the north negligible, and so it wouldn't necessarily have started out at 0 teslas, and it would have interfered with our experiment. We would have gotten inaccurate results. What if you were to stick two identical magnets together end to end and run this experiment again? How would you expect your measurements to differ? Well, I would say that the measurements would almost double. Not quite, but probably pretty close, and then the magnetic field wouldn't actually differ. So conclusion, we were able to use the Biot-Savart law to measure magnetic fields and to calculate mu, and then we were able to set up a code to demonstrate this and show a model of our final results. The distance dependent we ended up with was negative 3.14 meters, and the mu that we got was 2.8. Thank you.